Welcome back, data enthusiasts. This is Roshan Surek Matthew, and this video series is all about answering some of the most asked data science interview questions. Now, if you want to check out different data science interview questions, make sure to check out the entire playlist. I'll add a link in the description down below. You can simply click the pop card at the top. Before moving forward, if you're new to the ANDS channel and like my content, please do leave a like, then smash the subscribe button and turn on bell notification to stay updated for more interesting content. Stay tuned. Now on to this video's topic, bias-variance trade-off in machine learning and how it impacts the model performance. Bias-variance trade-off is one of the most fundamental concepts in machine learning, and understanding this concept is crucial for acing data science interviews and for improving your model performance. So let's get started. To kick things off, let's define what bias-variance trade-off is. In machine learning, every model aims to achieve two essential goals. Bias. This represents how closely your model's prediction matches the actual values in the training data. It can be thought of as a systematic error in your model. A high bias means your model oversimplifies the data, leading to underfitting. In other words, it doesn't capture the underlying patterns in the data. Variance. This measures the model's sensitivity to fluctuations in the training data. A high variance implies your model is overly complex and captures noise from the data, leading to overfitting. Now in this case, your model fits the data perfectly but performs poorly on the unseen data. Now let's visualize this trade-off with a graph. On the x-axis, we have the model complexity ranging from simple models on the left to complex models on the right. On the y-axis, we have error, which includes both bias and variance. As you can see, when you have a simple model, it has a high bias but a low variance. It's not flexible enough to capture the data's complexity, resulting in systematic errors. On the other hand, as we move towards complex model, towards the right, the bias decreases but the variance increases. These models fit the training data very well but fail to generalize to new and unseen data. So how does this trade-off impact the model performance? Well, finding the right balance is essential. But if your model has high bias, it won't perform well on training data or the test data, leading to an underfitting. If it has a high variance, it may perform exceptionally well on the training data but terribly on the test data, indicating overfitting. So you might be wondering how to navigate this issue of bias-variance trade-off. Well, here are some methods by which you can reduce bias-variance trade-off. Bias reduction. To reduce bias, you can try more complex models, feature engineering, or increasing the dataset size. Variance reduction. To reduce variance, you can consider simple models, regularization techniques, or using more training data. Cross-validation. Using techniques like cross-validation to access your model's performance on different subsets of the data and fine-tune the hyperparameters accordingly. Ensemble methods. Combining multiple models to harness their strength and mitigate the weaknesses. To conclude, the bias-variance trade-off is a crucial concept in machine learning. Achieving the right balances between bias and variance is essential for building models that generalize well to new data. Remember, there's no one-size-fits-all approach. It depends on your specific problem at hand and the dataset that you're using to train the machine learning model. If you found this video useful, please give it a thumbs up and subscribe for more amazing content. Also, make sure to follow me on my social media handles to stay updated for more interesting content. Thanks for watching, and I'll see you in the next video.